So here we're going to solve this problem. This is a system of three equations in three unknowns. The three equations being this one, and this one. And the unknowns being x1, x2, and x3. Now, what I'm going to do is I'm going to use Gauss Elimination. Now, I may have mentioned this already, but I want to remind you, as I always do, of what these actually are. These are rules that allow us to transform one system into another equivalent system. And by equivalent system, I mean a system with the same solution set. So by following these rules, I will not change the solution set, but I will change the way that the system looks, so that at a certain point I reach a place in the I reach a system from which, from looking at it, allows me to get the solution or to determine if it has no solution. Thank you. Let's continue. Let's begin. So for this particular case, what I'm going to do is I'm going to let me see here. What I'm going to do is let me see here. For our convenience, I'm going to translate it into, wait, let me think here a moment. Stand by. For this example, I'll just leave it in equation form, okay? So the first thing I want to do is I want to find out what I want to do that will help me eliminate one of the variables, okay? So the reason, so the rules will allow you to do whatever you want with this system, and as long as you follow the rules, you can get an equivalent system. But the key goal, of course, is to try and solve the system. In our case, right? We don't want to just be doing calculations for no purpose. So what I can see here, and I'm going to walk you through my thought process, is this. I can see that I can find a number, in this case, based on this system, that'll give me a 6 in one place and a negative 6 in the other. And as far as the coefficients of the x1 is concerned. And so basically, if I were to multiply this first row, this first equation by 2, this second equation by negative 3, this third equation by negative 3, then I will arrive with a situation where the consequent system will have a 6 in the coefficient for the x1, a negative 6 in the coefficient for the x1, and a negative 6 in the coefficient for the x1 in the third equation. And what that'll permit us to do is then, in the next iteration of this process, to eliminate x1 from the two equations that are left over, that are from the two, I'm sorry about that. So now, stick with me here. So what I'm going to do is I'm going to multiply row 1 by 2, row 2 by negative 3, and row 3 by negative 6. I want you guys to write down an instruction set of how you're going to go from one system to the next each time, because that way when you're studying, you guys can have a roadmap of exactly what you did, and you guys will be able to follow your work. And in case you make a mistake, you'll be able to see what you were doing, so you can evaluate if you made a mistake or not. Okay, so this first row is going to be multiplied by 2. So that's going to be 6x1 plus 14x2 minus 34x3 equals 16. Okay. My second row, I'll multiply by negative 3. So that'll be negative 6x1 minus 3x2 plus 12x3 equals positive 6. Okay, positive 6. Because a negative 2 times a negative 3 is a positive 6. Now I'm going to multiply R3 by negative 6. So that'll be negative 6x1 minus 6x2 plus 18x3 equals 0. Okay? Now in the next iteration, again, as we did this, we started off with the idea that I'm going to get one of the variables to have one number and the others to have the additive inverse as the coefficients of that variable. Now I did it for variable x1, the variable in the first column, but you could have done that with any variable in any column. Okay, but anyway, I started with here. So now in the next iteration, what I'm going to do is I'm going to leave the first equation untouched, but for the second equation, I'm going to replace by the sum of these two equations. And in the third equation of my new system will be the sum of these two equations. So in shorthand, what I'm going to do is my old R1 is going to become my new R1. Okay, this is my old column. This is my new. Okay. My old R2 plus R1 is going to become my new R2, and my old R3 plus R1 is going to become my new R3. And so that's going to become the following system. Okay. Okay. So my first equation is just going to be copied over. So that's 6x1 plus 14x2 minus 34x3 equals 16. My second equation is going to be the sum of these two. Okay. So I have 6 plus negative 6. Boom. Gone. 14x2 plus negative 3x2. That's 11x2. Negative 34x3 plus 12x3. That's negative 20. That's negative 22 x3. And then I'm adding, so that's 22. And then here, how do you call it? And let me just double check this here. So 34 minus 12. So 2, 4 minus 2 is 2, and 3 minus 1 is 2. Yeah, that was right. Now I want you to notice something very important here. As you notice already, this second equation is going to be very nice because I'm going to be able to divide it by 11, and it's going to give us very nice numbers. Now finally, for this third row of this equation, if I add the x1s, 6 minus 6, that's 0. Now I'm going to add these two. 14x2 plus negative 6x2, that's positive 8x2. Right? And then here, the negative 34x3 plus 18x3. Let me see here. 34 minus 18 is going to, 4 minus 8, I can't do that. That's going to become 2, 14. 14 minus 8, 6. 2 minus 1 is 1. So it's 16. But since the negative 34 is the number with the larger absolute value, it's going to be negative 16x3. And that's going to be 16 plus 0. That's just 16. Okay? Okay. So now here, what I want you to observe is that we have transformed this system into a system where the two bottom equations no longer have x1. And our next goal is to eliminate x2 from one of these equations. But we can't do that right away because we can see that we can't add these to do that yet. But one of the very nice things about this system is that if you look at both of these equations, let me see, if I were to divide out, they're both very nice in terms of like what happens if you divide them out. So what we're going to do right now is we're going to divide out this equation by 11, this equation by 8, and this equation by 2 to get them in kind of smallest terms, okay? So my old, so let me make this, let me state what I'm going to do here. I'm going to multiply row 1 by 1/2, row 2 by 1 over 11, and row 3 by, let's say, in this case, I'm going to multiply this one by 1 over 11. So in order to make sure this one's the opposite, so that when I add them in the next step, I'll be able to eliminate it, I'm going to multiply this one by negative 1/8, okay? Okay. So this first row gets multiplied by 1/2. What I want you guys to also realize is that at each step, I'm keeping the system together. And that's what I want you guys to realize, that I'm using these rules, the Gauss Elimination rules, to transform the system at each step into a system where it's easier to see what the final solution is going to be. So there's this 3x1 plus 7x2 minus 17x3 equals 8. Okay? This one I'm dividing it by 1 over 11. So that's going to be, okay, so here I'm going to multiply this one by 1 over 11. So that's going to be x2, because 11 over 11 is 1, minus 2x3 equals 2. And I'm going to divide this, I'm going to multiply this one by negative 1, 8, which is essentially the same as dividing by negative 8. 8 divided by negative 8, negative 1, so negative x2. Negative 16 divided by negative 8, plus 2x3. And then 16 divided by negative 8, negative 2. So this is my new system. And now, in the next step, what we're going to do is we're going to replace these bottom two equations by the sum of, we're going to replace the bottom equation by the sum of these two equations, okay? And so let me do that here. Stand by, please. And so here's our system that we had gotten on here. I just copied it over here so you don't have to see that time go just to me erasing it. And so now, what we're going to do, as I mentioned earlier, is that the top equation is going to stay the same. The second equation is going to stay the same. But the bottom equation is going to be replaced with the sum of these two equations, okay? So my R3 plus my R2 old, okay, this is my old, is going to become my new R3, okay? So the first two equations are going to stay the same, okay? So 3x1 plus 7x2 minus 17x3 equals 8. Here, x2 minus 2x3 equals 2. And now here I'm going to add these two. x2 minus x2, boop, gone. Negative 2x3 plus 2x3, boop, gone. 2 plus negative 2, boop, gone. So they're all 0. So what I end up with here is 0 equals 0. Now I want to point out something here. You might say, by the way, let me also mention a point. This is called reduced echelon form, okay? But anyway, so now I want to make a point here about what this result tells us. This situation where we have 0 equals 0, although it's an opportunity to make a smiley face, okay, that's not what it tells us, okay? I couldn't help throwing that joke in, okay? Okay, but what this tells us is that this is a system that has infinitely many solutions, okay? If it had been 0 equals to 2, or if these two numbers had not matched, then we could have immediately concluded that this system had no solution, or to use more technical terms, that this system was inconsistent. Okay. So basically now, here's how we're going to solve the problem. How we're going to find the solution. I'm going to pick a variable to serve as a parameter. And I'm going to pick the x3 to be that parameter. Because what you can see here is that I can take this second equation, okay? So let me do that here. So from the second equation, okay, I can see that x2 minus 2x3 equals to 2. I can add 2x3 to the left to get rid of it from the left, and I can add 2x3 on the right to get rid of it from the right. I mean to move it over. Whatever I do to one side, I do to the other. So I get x2 is equal to 2 plus 2x3. Okay? So let me write that down here. Let me summarize that here. x2 equals to 2 plus 2x3. Okay, now, what we're going to now do is we're going to rewrite equation 1, and in place of x2, I'm going to substitute this value of x2, and I'm also going to move over the x3 to isolate the x1. Okay? So so let me show you that here. So let me notate here what I'm doing here. So from x1, from equation 1, I'm sorry. We have 3x1 plus 7x2. But again, we already concluded that x2 is this. So I'm going to put that in here. 2 plus 2x cubed minus 17x3 equals 8. I'm going to distribute the 7 in here. Okay, so that's going to give me 3x1 plus 14, because 7 times 2 is 14, plus 14x3, because 7 times 2 is 14, then minus 17x3 equals 8. Okay? So now what I'm going to do is I'm going to just simplify it one more time, then I'm going to isolate the x1. So 3x1 plus 14 minus 3x3 equals 8. Because 14 minus 17 is negative 3. Now, I'm going to add the 3x3 to the other side, add the 3x3 to the other side, subtract the 14 to the other side, subtract the 14 to the other side, and I'm going to get 3x1 is going to equal 8 minus 14, that's negative 6, plus 3x3. Okay? And if I divide the whole thing by 3, I can get that x1, actually. Let me copy this over here. You're going to see what I'm doing here. So x2. So the 3x1 equals to negative 6 plus 3x3. I divide by 3 here, I get left with x1. I divide negative 6 by positive 3, I get negative 2. And I divide the 3x3 by 3, and I get just x3. And so this is my solution. And what you can see is that the terms after this triangular system, I had this x3 on this side. So I added it over, and that's how I chose to make my x3 my parameter. And so for any value of 3, I will get a solution of the system by selecting x1 to be negative 2 plus that x3, by selecting x2 to be 2 plus 2 times that x3, and by selecting x3 as x3. And so if I wanted to, I could relabel it as a parameter. I could relabel it as t, where t represents a real number. And I could rewrite this system, I could rewrite this solution as x1 equals negative 2 plus t, x2 equals 2 plus 2t, and then x3 equals t. Or I could write it as a point, where this would be my coordinate for my first point, this would be my coordinate for my this would be my second coordinate for that point, and this would be my third coordinate for that point, okay? And so this is a solution with infinitely many, this is a system with infinitely many solutions, at least one, and you can see them like this. And in fact, let's just do a brief example to see that this works, okay? In other words, let's test this out, right? You're like, David, you're not going to leave us hanging. You're not going to double check this, right? And I'm like, of course not. What do you think I am, a monster, to leave you guys without having tested this system? Never! No! So this is my solution in terms of a real for t some real number, right? Okay. We could even use this to eliminate like we could even use this to rewrite them in terms of each other to find the solution set. But anyway, so now let's look at a particular solution. Let's say t was 0. If t was 0, comma, then our solution would be x1, which would be negative 2 plus 0, which is negative 2. Our x2 would be 2 plus 2 times 0, which would be 2. And our x3 would just be 0. Right? Okay. Now let me test to see if this works in the first equation. I'm going to calculate the left-hand side. I'm going to label that left-hand side of equation 1. Okay. That's going to be 3 times my x1, which we saw as negative 2, plus 7 times my 2, minus 17 times 0 equals what? Here, 3 times negative 2, that's negative 6, plus 14 minus 0, and we can see that that is 8, which is exactly what we expect from the right-hand side, right? How do we test the second equation? The left-hand side of equation 2. By the way, what I'm doing here is I'm double checking, and I want you to develop this habit too. Whenever you can double check an answer, you should double check it also, because that's the only way you can know if you're really doing it properly. So now I've copied the left hand side, but in it I've substituted my x1, my x2, and my x3. 2 times negative 2 is negative 4, plus 2, and then minus 0, which is negative 2. That's exactly what we expected from the right hand side. Finally, the left hand side of equation 3 is negative 2 plus 2 minus 3 times 0 equals, well, here you can see negative 2 plus 2, that's 0, minus 3 times 0, that's 0. So 0 minus 0, 0. And so what we've just shown is that this particular solution satisfies all the equations in the system. If you wanted to, we could also plug these in to each equation to see that they satisfy the system in general. Let's do that here. Even though it's strictly not necessary, I just want to do it just for fun, because why not? Might as well at this point. So the left-hand side of equation 1, okay, 3 times negative 2 plus t plus 7 times 2 plus 2t minus 17t, and I'm going to simplify this. So it's going to be negative 6 plus 3t plus 14 plus 14t minus 17t. You can see that we have negative 6 plus 14, that's positive 8. 3t plus 14t, that's 17t minus 17t, that goes to 0. So in fact, this general solution, the solution in general, has just satisfied the first equation. What about the left-hand side of equation 2? Okay. So I'm going to plug in 2 times my x1. What's my x1? It's negative 2 plus t plus my x2, which is 2 plus 2t, and then minus my 4 times t, because that's my x3. So I'm going to simplify this. It's going to be negative 4 plus 2t plus 2 plus 2t minus 4t. Negative 4 plus 2 is negative 2. 2t plus 2t, that's 4t, minus 4t, that's 0. That's exactly what we would have expected from the second equation, and so we can see that this general solution that we evaluated does in fact satisfy the second equation and the first equation now simultaneously for any value of t whatsoever. We are now in a position to substitute into the third equation to verify that this works. Okay, so I'm going to plug in my x1, which is negative 2 plus t plus 2 plus 2t minus 3t, because t is my x3, right? And then equals, well, negative 2 plus 2, that's 0. T plus 2t is 3t, minus 3t is 0. We have just shown that in general, oh, this is the left-hand side of equation 3. We have just shown that the general solution also satisfies the third equation. So to put a complete pin on it, we have just shown that for any value of t whatsoever, this general solution will solve the system. Okay? And what I also want you to realize is this. As t varies, it'll trace out the solution in the plane. And let me see here, stand by. I hope you all have enjoyed this solution, and I look forward to seeing you again soon. Thank you so much.